So greetings to all. In this video lecture, let's solve a problem for Shannon Fano coding. Okay. So the question is, for discrete memoryless source with 6 symbols x1, x2 up to a6 has probabilities 0.3, 0.25, 0.2, 0.12, 0.08 and 0.05. Find the code word using Shannon Fano algorithm. Okay, so in the question we could see there are 6 symbols given: x1 to x6, x1, x2, x3, x4, x5. That has probability 0.3, 0.25, 0.2, 0.12, 0.08 and 0.5. Okay, we are asked to find the code word using Shannon Fano algorithm. So before we proceed, let's discuss the steps involved in Shannon Fano coding. Okay, so here is a list of steps that we have in Shannon Fano code. First one is create a list of probabilities or frequency count for the given set of symbols so that the relative frequency count of occurrence of each symbol is known. Okay, first one is from the question we need to create the list of symbols along with the probabilities. That's what they mean to say. Second one is sort the list of symbols in decreasing order of probabilities, the most probable one on the top and the least probable one to the bottom. Second step, the first one is you just take the whatever list and arrange by its list and its probabilities. Second step is we need to sort the symbols based on its probabilities. Okay, I mean in decreasing order, that is the highest probability should be on the top and the least probability to be on the bottom. Okay, split the list into two parts with the total probability of both parts being at close to each other. For example, the sum of probability will be usually 1. Okay, so we need to ensure we need to split the symbols in such a way that we can divide the symbols based on the probabilities 0.5 and 0.5. But sometimes we call this as equiprobable because we may not be able to divide the symbol exactly as 0.5 and 0.5. We need to partition in such a way we can do it very close to it. Okay, so then once we do it, assign the value 0 to the top part and 1 to the bottom part. Okay, repeat step 3 and 4. That is, we're going to split it again and again into equiprobable so that it becomes equiprobable and split into individual groups. So we can repeat the steps again and again until we get the individual symbol. Okay, so repeat step 3 and 4 for each part until all the symbols are split into individual groups. So once we do that, the last step is generate the code word for the each symbol. Okay, these are the steps involved. So let's solve a problem for Shannon Fano coding. Okay, so as I said, we have 6 symbols here, x1 to x6. First we will write it down: x1, x2, x3, x4, x5, x6, and we'll write their probabilities. Their probabilities are 0.3, 0.25, 0.2, 0.12, 0.08 and 0.05. Okay, so these are the symbols and the probabilities. So first step is arrange in descending order. So from the question itself we could see by default it is in descending order, so that's not an issue. Next one is we need to divide the symbols into half based on the probabilities. For example, now where should I divide? If you see the sum of probability, it should be equal to 1. Okay, sum of probability, usually the sum of probability will be equal to 1. Now if you divide it, okay, if you just divide the probability 1, it should be 0.5 and 0.5. Okay, so where exactly can we divide? So if we divide it here, okay, if you put a division here, it will be 3. the one side will be 3. If you just add this together, 0.25 plus 0.2 is a 0.45. Then again 1 2 is 4 5 plus 5 5 and 5 7. Okay, 0.57. Then adding this 0.08, 0.57 plus 0.08 becomes 0.65, right? So this will become 0.7. So if you just put and split here, the above part will have probability 0.3, and this portion, if you add some probability 0.7. So where do you split? Either if you want to split into half, which one will be the correct split? Either to split here or split here. So if you see exactly the second here, this will be the perfect split, because the here if you add, like, you know, the if you're going to just make a split here the probability is going to be 0.55, and if you add this here, the probability is going to be 0.45. Okay, so I think rather than splitting here, we can't split exactly 0.5 and 0.5. The best option will be to split here, right? To split here. So once I make the split, assign the value 0 to the top and 1 to the bottom. Okay, so we are going to, now this is a separate stage, now this is a separate section, and this is a separate section. Again we are going to follow the same step and repeat it again and again till we reach the split for an individual symbol. Okay, now if I split this again, I have only two options. I have only one option, that is I have only two symbols. So I'm going to split it. This is going to be 0, this is going to be 1. There's no other option anymore, right? So this will put as stage 1, this is stage 2. Okay, now the top portion is a separate thing and the bottom portion is a separate thing. Okay, now where should I split here? Okay, so if we add the total probability, this should be around 0.45, right? 0.45. So if we add this 5 plus 8, 0.5 plus 0.8 becomes 0.13. If I'm going to put a split here, just imagine this is going to be 0.32 and 0.13. It won't be equiprobable. So if I want to divide exactly, I think the best option will be to split here. Okay, now this has a value of 0, and after whatever below has a value of 1. Okay, now this is splitted individually, there is nothing else here, that's it. This is an end to it. Now we have 3 options here. Now where do I split? If I split here, again it is not equiprobable, so I need to do my next split here. This will become 0. This is my stage 3. Okay, yeah, this becomes 0 and the rest becomes 1. In stage 4, I have only 2 options. One is this becomes 0 and this becomes 1. Now to write the code word, it's very simple. Just put this, combine these, symbols, and that forms the code word. So the code word for x1 is 0 0. The code word for x2 is 0 1. The code word for x3 is 1 0. The code word for x4 is 1 1 0. The code word for x5 is 1 1 1 0 1 1 1 0. The code for x6 is 1 1 1 1. Okay, so this is the code word for each symbol using Shannon Fano coding. So what do you mainly observe here is the probabilities that have maximum are higher the probability, lower is the length of the code word. Length of the code word is nothing but the number of bits. So what you can observe here is higher the probability, lower the length. Okay, so if you see the probability is decreasing and the length will get increase. Okay, so this is one reason why we uh, go for this Shannon Fano algorithm. This is also like the same with Huffman coding also. Like if you have any doubts in Shannon Fano coding, you can please uh, ask me.